Welcome to this video on the topic of data compression. In this video, we're going to have a look at something called fixed code data compression. Data compression is the act of reducing the memory burden of a file on a computer's memory. A simple technique we can use to achieve this is through re-encoding symbols using custom encoding systems. Such systems can be referred to as fixed code compression systems. This can be seen in the example we have over here. So what we've got is the information hello world. Now typically on a computer system, this is going to be encoded in the ASCII encoding system, of which it takes 8 bits for every single symbol that we want to encode. So in our case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to have 11 times 88, 11 times 8. And that's how many bits we need to represent all of the information here. In terms of bytes, we divide it by 8 and we're going to use 11 bytes of information. Now, looking at this symbol, looking at the sentence over here, what you notice is we're only using a very small amount of the 127 available characters in the ASCII encoding system. As a result, we don't need all 8 bits to represent the information in this sentence. Rather, because we only have 8 unique symbols here, we can get away with only using 3 bits. So as a result, the memory requirements to show this sentence over here is going to decrease. Now the way in which we can calculate this is we go 3 bits divided by 8, and then we go times 100, and what we're going to find is that the re-encoded sentence is going to take up 37.5% of what the original sentence did, simply using this fixed code compression we see over here. So what we can see is that using shorter codes, it is possible to express the same information with less memory requirement. Now to be able to build a custom compression table, we have a few steps that we follow. Now the 4 steps we follow is, in the first one, we create a tally and frequency table from the symbols within a sentence that we're trying to compress. Secondly, we convert the tally and frequency table into a sorted symbol and frequency table, after which we build an encoding tree, and then finally we extrapolate the coding from the tree itself. Now there's quite a lot of jargon here, so what we'll do is we'll use an example to demonstrate how this process can be carried out. Now the sample that I'm going to carry this process out on is the simple text hello world. Now the first step that we're going to do is we're going to create a tally and frequency table from the symbols within the sentence. When I refer to symbols, what I refer to are the letters in the sentence. The reason I'm using the word symbol is because it's just a generic way we can refer to letters, numbers and characters. Now building the tally and frequency table, what I need to do is I need to have a symbol, then I'm going to have a tally, and then I'm going to have my frequency. Now for the symbol, what I'm going to do is I'm going to go through the sentence left to right, and every time I see a new symbol, I'm going to add it to the symbol list over here. So the first one is going to be H, followed by E, then we have a L. Now we've got a second L, however we're going to ignore it because we're not going to do double ups in our symbol table or our symbol list. Rather, we only have the symbol once. So we skip the second L and we go for an O, followed by a space, W, R, and D. So what we've got over here is our list of unique symbols. We have 1, 2, 3, 4, 5, 6, 7, 8. Now our next step is we're going to go back over the sentence, and every time we see the instance of a symbol, we're going to add one to the tally. So we have big H, little e, little l, another little l, O, space, W, another O, an R, third L, and then finally a D. Then finally, to finish this off, we simply do the frequency. So it's 1, 1, 3, 2, 1, 1, 1, and 1. Now completing the table, I'm just going to draw in the rest of the grid. So this is step 1. We have created a tally and frequency table. Now for step 2, we need to convert the tally and frequency table into a sorted symbol and frequency table. So what does this mean? Well, it means that we're going to drop the column that says tally because the information isn't required, and we're going to have a symbol and frequency. Now it says sorted in that we're going to sort the table in the order of frequency. So for a higher frequency, we're going to put that at the bottom of our table, and for the lower frequency, we'll put that at the top. In the instance that we have symbols with the same frequency, then we'll just do it in any order. It's not particularly important to have the symbols themselves sorted, just in terms of frequency. So putting this together, we're going to have symbol, we're going to have frequency, and then we're going to have a code on the far right that I'm not going to put in just yet. Now sorting out the symbol, we have H, we have E. Now we could go L, but that's quite big, so I'm going to skip it. I'll skip the O, and then I'll go space W R L D, followed by that, D, followed by O, and then finally L. So our frequency is going to be 1, the same, 2, and then finally 3. So what we've got over here is our sorted. So we've got our sorted symbol and frequency table. Now the third column in this table is going to refer to code. However, I'll show you how to generate that next. Now in the third step, we're going to build an encoding tree. Now the encoding tree is simply a binary tree, but in this instance we're going to draw it upside down, and it will make sense once we finish drawing it. So first thing I'm going to do is I'm going to get all the symbols and I'm going to list them in a row. So I'm going to go H, E, space, W, R, D, O, L. Then I'm going to box them all up. So these are items in a tree. Alright, now next step is I'm going to start merging these items together to reduce the amount of branches in the tree. Now to do this, I'm going to get H and E, and they're now going to be besties. Space and W, they're now going to be besties. R and D are now going to be besties, and O and L are now going to be besties. And thus our tree is going to start taking shape. So E and H and E, space and W, R and D, O and L. Alright, next step, what we're going to do is we're going to repeat the exact same process that we just did, thus merging the tree into smaller sections. So we're going to get H and E, which is going to merge with space and W. And then we're going to get R and D and merge that with O and L. Putting this together. And then finally, we need to bring the final two trees or final two branches of the tree together. So we've got H, E, space, W, R. So what we've got now is we've got our encoding tree. Now the next step is we're going to label the branches on the encoding tree. Now all of the branches on the left, we're going to assign them the value 0. And all of our branches on the right are going to be assigned the value 1. Now next step is we're going to extrapolate the code from the coding tree that we see over here. So if we were, for example, going to say what is the new code for the letter H, we're going to look for H in our encoding tree and we say 0, 1, 0, 0, and then we're going to write that out backwards. So we go down the tree, then we go back up the tree. So 0, 0, 0, now starting 0, 0, 0. Alright, next example, E. We look for E up here, we go down the tree, then we go back up. So it's 0, 0, 1. Across the space, we have 0, 1, 0. And then across to W, we have 1, 1, 0, which becomes 0, 1, 1. Across to R. Done. So what we've been able to do is we've been able to extrapolate the unique codes for each of these symbols and put them in our symbol and frequency table. So what we're going to find is that if we want to encode this message over here using our custom encoding system, then what we can write it as is H is going to be 0, 0, 0. E is going to be 0, 0, 1. L, we're going to go 1, 1, 1, and there's 2 of them. O. And thus what we've been able to manage is we've converted what would have been the ASCII encoding system here and implementing our own encoding system, and thus reducing the memory burden required to store this information on our hard drive. Now, looking over here, you might have already picked up with the coding itself, is that all we're basically doing is we're counting upwards in binary, so 0, 1, 2, 3, 4, 5, 6, 7, and you would be right to notice that. Now, the reason we've started off by building these trees over here, it's going to enable us some practice from transitioning from fixed code encoding or fixed code compression into something called Huffman compression, where we're going to find that the structure of the tree is not as simple as what we have over here. So in conclusion, what we had a look at in this particular video was we had a look at data compression, of which we looked at fixed code compression, and then we had a look at the 4 steps we can use to apply a fixed code compression algorithm to compress information shown over here.